the unit tangent vector. So from previous discussions, we have talked about the velocity vector, which is v here. We know that the velocity vector points in the direction of motion. It is tangent to the curve r of t. And so one thing that we can do is that assuming that v is not the zero vector, which is basically saying that our particle moving along never stops moving, there's no place that comes to a rest, we can define the unit tangent vector. So this right here, t, is the unit tangent vector, and it's defined to be, you take velocity vector v, the tangent vector, and you divide out by its magnitude. This is how you take a vector and turn it into a unit vector that is pointing in the same direction. And so sometimes we care about this unit tangent vector. There's important reasons to care about it. So let's just do a couple of examples here. So find the unit tangent vector of the curve. R of t is 1 plus 3 cosine t I hat plus 3 sine t j hat plus t squared k hat. Okay, so if we do this calculation here, v, we take the derivative r of t, and we would get negative 3 sine t times I hat, that's the derivative of 1 plus 3 cosine t times I hat, then plus 3 cosine t j hat plus 2t k hat. Okay, so this is v. Now we need the length of v. What is the length of v? What is the magnitude of v? We simply do the square root of the sum of the squares. Negative 3 sine t squared plus 3 cosine t squared plus 2t quantity squared. So this would be 9 sine squared t plus 9 cosine squared t plus 4t squared. Of course, sine squared t plus cosine squared t is 1, so this is just the square root of 9 plus 4t squared. Okay, great. We have found the magnitude of v. So we are ready to say what is our unit tangent vector t here. T is equal to 1 over the magnitude, 9 plus 4t squared, times v itself. So negative 3 sine t I hat plus 3 cosine t j hat plus 2t k hat. And of course you may want to rearrange this so everything, we have this component by component. So negative 3 sine t over square root 9 plus 4t squared I hat plus 3 cosine t over square root of 9 plus 4t squared j hat plus 2t over square root of 9 plus 4t squared k hat. Okay, and so what is this vector down here? This is a unit vector that points tangent to our curve for any value of t. Okay, so this is all well and good. Let's do one last example to wrap up this video, to wrap up this section, actually to wrap up this chapter for us. Find the unit tangent vector for a very simple example here. R of t is cosine t I hat plus sine t j hat. The k hat component is 0. So once again, r prime of t is negative sine t I hat plus cosine t j hat. That is v of t. The magnitude of v is the square root of negative sine t squared plus cosine t squared. This is sine squared t, this is cosine squared t, square root of 1 is 1 here. And so you know, our t is just simply v divided by 1. It's just v is negative sine t I hat plus cosine t j hat. What's going on pictorially here? So cosine t I hat plus sine t j hat. So that would be we are going around a unit circle. We are going around a unit circle here, and the important kind of fact here is, so that is an example of what t is here. So as you're going around the circle, this is tangent to the curve. This vector here is tangent to the curve right there. So this is a nice important example. Okay, hope you enjoyed all of these videos so far.